The goal of Data Transformers podcast is to accelerate digital transformation by bridging the gap between business outcomes and rapidly advancing technologies. And we aim to bridge this gap by focusing on data. I am Peggy Tsai, top 50 women in tech influencer, co-author of the AI book, and data governance expert.
I'm Ramesh Danta, an entrepreneur, a tech blogger, and AI enthusiast. Welcome to Data Transformers podcast. Today, I'm excited to bring a friend of mine who I connected with on LinkedIn back in 2016. His name is Vashishta. Vashishta is the chief data scientist at Data by V Squared, editor at the ML Rebellion, and LinkedIn's top voice for 2019. Vin, welcome.
Thanks for having me.
Welcome, Vin.
Thank you.
All right, so finally we are making it possible, Vin. Interview with you. Would like to get to know you more. And I was looking at your profile, and the first question that came to my mind is, okay, fine, he's the chief data scientist, ML Rebellion, and top voice. But I want to hear from you. How do you position yourself? Who are you?
Oh, that's a great question. My goal has always been to be able to say, hi, I'm Vin, and everyone just kind of knows who I am and what I'm doing. Not quite there yet. What I do is sort of it's a three-ring circus. I'm on the strategy side, business strategy. So I teach companies, I talk to senior executives, senior decision makers, sometimes even board of directors about machine learning, specifically now about monetization, and it sort of gets into the path to production. Try to figure out how to, one, compete with your machine learning companies, some of your larger companies that are coming into the spaces that you wouldn't expect Amazon to be in, or you wouldn't expect Google to be in, that all of a sudden they're starting to creep into. And so I talk to companies both about building their own capabilities and building their own strategies, as well as sort of how to compete against these behemoths. The other side, second ring is really just content, social media. I do a lot of writing. I do a lot of sharing. I love talking with the community and interacting with the community. So you see me write probably too much, post a little bit too much.
Not too much.
Okay, that's good. I do a ton of interviews like this one. So this is a big part of, this is my second ring of the three-ring circus. And I still do machine learning product development. Right now I'm working on decision support systems, which is a really, really interesting facet of machine learning that's coming up, and helping people make complex decisions under uncertainty, getting better data. And that sounds simplistic, but it's more complicated than it sounds to get the right data to people at the right point in this whole process of decision making, especially when it's a complex chain of decisions. Mm-hmm. And it's collaborative, and learning really what's the right information to provide, what's the right format to provide that data in, and then what's the outcome. If I present this data to a person, have I improved the decision outcome? Have I, by presenting an entire dashboard to a different group of people, different data, different times, have I improved the overall outcome of the sum of all of those decisions? Have I allowed people to understand there's more decisions than maybe they saw in the first place? And so it sounds really, really simple, but the machine learning behind it and the algorithms behind it are extraordinarily complex. But to the user, it just looks like a dashboard.
You said earlier, interesting comment, I want to elaborate a little bit more on monetization. Mm-hmm. And I think that's really the reason why a lot of companies and organizations today are, focusing so much on machine learning, is because they want to, one, make better decisions, and two, obviously monetize on the decisions to further improve their organization. How do you think about specific business problems, or how do you help companies exactly figure out the monetization factor?
Monetization is difficult because every company has different capabilities. So that's where it starts out, is determining whether the company are you a machine learning first company? Are you a company that really is more of a traditional business model. I call them legacy business models, but it doesn't sound as good as traditional business model. And those are companies that are not machine learning first. They are machine learning capability builders. They build through bringing people into teams, and in a lot of cases, buying software from other companies that will sort of help the products out. A lot of times it's mergers or acquiring smaller companies, buying IP. And so becoming data-driven isn't really the goal for everyone. Becoming machine learning first really isn't the goal for everyone. So it starts with sort of understanding. And in some cases, you don't need machine learning. So there's these three categories in this big spectrum of you have to figure out which category you're into. And once you know, that's going to drive monetization strategy. From there, you decide if you're a machine learning first company, you are building machine learning based products where people are not paying for a product. And then there's this cool feature that's based on machine learning. Like a good example is Netflix. They have a recommend where you see, hey, check out this thing next. And no one pays for that feature, but that feature does a whole lot for Netflix. It drives a whole lot of engagement, but no one pays for that feature. And even though Netflix is a really machine learning driven company, and there's a lot of very, very talented people that work for Netflix, it in some ways is not a machine learning first company. But other companies where core components of their business model depend on machine learning. And that's where the real monetization happens. That's where a company has to begin to understand that the product is not going to have machine learning kind of over here and the product's this huge thing that sits on top of it. It's really machine learning. And then there's this little piece of product or interface or something else down here. But the core component is machine learning and trying to understand how to monetize everything from the data that you may be gathering that could be a completely unique data set that could be monetizable. You could be selling this to any number of different people. There's a lot of companies that do that who are not so publicly known data brokers. Infinity is one of those. Nissan, Infinity, they take data and gather data in their cars, and they package that up and sell that to insurance companies, and a lot of marketing data also comes out of those cars. And so they've monetized machine learning. And that's something that not a lot of companies have really come to grips with, is the data that comes from a lot of these smart technologies that have just a little bit of machine learning, but they're gathering a whole lot of data, and that data is unique. It's curated by the machine learning algorithms. And so it's monetization there. And then you're also talking about products. These, like I said, these very, very machine learning algorithm heavy products where the competitive advantage is, in a lot of cases, I hate to say it this way, but it's the algorithm. And there's this whole movement away from, it's all data. If you have more data, you don't need algorithm. No, that's wrong. That is completely wrong now. It was true 2 years ago. It is not true now. We have to move away from the data is everything mindset and come back to, we need to get really smart about how we're building models. And we need to go more towards the structured, transparent, capability aware, robust, and eventually moving towards causal modeling.
Actually, when you're bringing a good point there, there's a lot of debate going on, right? So as you said, in the past, it's about the more data that you can feed into the engine, then the better decisions, the better predictions you get. But now there are two things happening. One is that how can you have a model where there's a limited data, right? And then that's one aspect of it. The other aspect of it, what people are saying with the COVID, whatever historical data that you had, like take airlines as an example, right? How you price and all that models based on historical data, and they may not have any relevance going forward. So you have to assume that there is no data, right? As a result, how can you have better machine learning? That's where another argument is coming from. So are you saying that now we can go and predict based on limited or no data?
Well, I think there's two pieces that I want to cover with what you said. And when it comes to conventional wisdom about COVID and the impacts on machine learning and models, you're completely right. When it comes to conventional wisdom, I would say, and this is something that I'll have to back up And COVID has changed nothing. COVID has revealed that models were broken in all along. COVID data is no different than all the data you had before. And that's really difficult to wrap your head around, because you look at COVID and you say, no. COVID has changed buying behaviors. It hasn't changed behavior. The way people were and the way people make decisions before COVID is really built on the same foundations as they're making decisions after COVID. And you can see this in something as simple as masks. There is an entire segment of the population who doesn't wear masks. There's no, well, I mean, it's a piece of cloth, put it over your face. People, when they get cold in the wintertime, will put these scarves over their face. Yeah. And this is the core of decision making. And so when you talk about a pricing model, especially the decision making of the person looking at the price of the person who is deciding whether to buy or not, fundamentally that hasn't changed. The emergent behaviors of those dynamics have changed. And that's where you're right. So when you look at the data, depending upon where your model fits and what really your model is understanding, what system does the model understand? Does the model simply extend the data set? And in many cases, that's what it does. It is an extrapolation of the data set in another form. And that can be valid as far as a deployed model in production. You can get a lot of value out of that as a company. Those are the models that fail in COVID because they've modeled data. And since the data that you are now gathering, the data that's going into your model is different, the model breaks because it's not modeling the new data, it's modeling the old data. And you hear these concepts of drift, you start talking about monitoring your models in production. Yeah. And that's really why all of this is coming forward, is because we've built a lot of models that model data sets, but do not model the more complex systems under measurement. And so it depends on what kind of model you have in production, how much that model has really gotten into the system that you're trying to measure and how deep you've gone into it. That's going to depend, or that's going to determine in a lot of cases, how much of the model is still functional. And so, like I said, you are right, especially with the trend and the way that a lot of models work. However, the deeper the understanding of the system under measurement, the better the model functions in that way, that it understands the system rather than the data. The more predictive capabilities it has, the more reliable it becomes, the more capable of wear in a lot of cases it becomes. And so this whole concept of monitoring, in many cases, the model tells you, like I started getting phone calls in January about issues with models and performance degradation. And it's because we've built some capability aware models that come back and say, I really shouldn't be making predictions right here because I have no level of certainty that you could trust. And when you start seeing that come back from your monitoring systems, you know, you're right. We are now experiencing some data that we don't have a lot of precedent for. And then talking about smaller data sets, what that forces you to do now that you've been modeling data and the data is different, you don't have a lot of data, it really forces you to go back and begin to create more complex models that instead of mimicking the data, you go deeper. And in some cases that means experimentation. In some cases that means, I don't want to spend 20 minutes on this answer, so I'm going to cut it short. Yeah. But it means more rigorous machine learning and more rigorous science behind the data science. So a lot of models that are out there right now, like I said, they work fine. They're very valuable. The people that built them are very, they're very business aware and they've done some great things for their companies. But in extreme situations like these, the weaknesses are revealed.
See. So Vin, I was actually looking at some of your recent LinkedIn posts, and I know you write a lot about different topics. One that struck me was about a model, machine learning around hiring. And I was wondering if you could talk about that, because it's been in the news certainly in the last couple of years where companies, I won't name them, some tech companies use just AI algorithms to vet through their resumes, and as such, those machine learning were biased to begin with, and the results obviously is a, dysfunction of who they hired and just the percentage of men and women, et cetera. So can you talk a little bit about some of your thoughts on that type of modeling?
Yeah, I mean, I'll say Facebook, Amazon, even Google. Google especially very recently got very, very, very serious about becoming a more diverse company. And I know we give a lot of these companies a hard time. We say, they should have, they could have, here's what we're seeing that they're doing wrong. But they're the transparent ones. The research that I've done, if you look at small companies, the numbers, the diversity numbers in smaller companies are the overwhelming cause of the problem. Companies like IBM, companies like Amazon, Google, Facebook, Microsoft, all of these companies are trying, and they're trying stuff that doesn't work. They're forcing culture. They're working against a whole lot of infrastructure that goes back 50, 60, 70 years. For some of these companies like IBM, it's been baked into IBM for such a long time that the amount of work they've done, they should get some credit for. It's not enough. But what we really have to understand is how much each one of these companies has to undo and rebuild. And that's the part that we're not exploring enough, because it sounds like, what I said sounds like I'm making an excuse for a company to have not done as much. But it's the study of each one of those tiers and blocks of sort of legacy, bad hiring worse practices, hiring that really stemmed from bias. And it's understanding those that will help us just as a global ecosystem to start working towards hiring more diverse people and more of a diverse workforce. And a lot of that, when I start to dismantle it, you begin to see this concept of sort of self-disqualification. And this is really interesting because it's easy to dismiss. And you heard Wells Fargo's statement. I'm just going to leave it there. I've never seen a foot that far in someone's mouth before, but that's a sentiment that's real. And we have to admit that. We have to admit that there are a huge number of people who just won't say that. The candidate pool is not big enough.
Yeah.
And they're right. However, they're not looking at it correctly. So, and here's a lot of our problem with diversity and discrimination, is you can say something which is factually well established, but is still wrong because the data has been overextended. And this is a huge problem across data science and machine learning, is we very often come to a conclusion which sounds supportable, but it isn't. And so what really happens is you have candidates who, because they have been biased against, because there is this sort of legacy for them of sometimes 10, 15, 20 years of career, sometimes spanning back beyond, into their education, into their early education. They've been victimized by bias for so long that they begin to self-exclude. And what we are studying, the data that we study almost by and large in the industry, is data of people who have succeeded in overcoming bias. These are the people who are in the talent pool. And so we're studying them and saying, why aren't we hiring more of these people in the talent pool? But what we're not looking at is there are people who classify. If you look at their job, or if you look at a particular job, and if you look at their resume, they should classify as a higher role than they do. And you begin to sort of unravel what leads to a person self-excluding from a job, not applying for a job, someone who does not put their full skill set onto their resume. And this happens, women are a good example of it. There are many cases where you can see a woman whose career was obviously not advanced as quickly as it should have been. They speak far more rigorously about far fewer capabilities because they have been, this is hypothesis. It's very, very hard to prove this because the number of interviews I would have to do would be I simply don't have access to that data at this point. But based on what I'm seeing, my suspicion is that a woman feels like she has to be able to defend a capability so much more in technology than a man, that the way a woman writes, in many cases, her resume or her profile isn't always indicative of her true capabilities. You'll also see that in people of color. You will see that I don't have enough data to really go any further than just this broad gender, broad protected class. I can't get specific enough because, like I said, I don't have the data to dive into each one of the demographics, but I can say that there is definitely a difference between a protected class who has experienced bias and how they describe themselves versus someone who is outside of a protected class and does not appear to have been, experienced the same level of bias. You will see different wording, and you will see, I don't want to say an overinflation of skill on one side, but a tendency to be more confident in skills that they have less experience with than someone who has experienced bias. And this is really the key of why we don't have big enough talent pools, is because we are not going that next step and trying to understand that people who don't apply to these jobs, their data is not included. And we need to start understanding their perspective. People who have experienced this systemic bias and who are discouraged, sometimes in the same way that people who are unemployed at some point become discouraged from the workforce. These groups are discouraged from advancement, discouraged from certain career paths. And so we're not studying those people, and we're not understanding that those individuals are able to take on these other roles. However, they do not describe themselves in a way that our automation and our machine learning pulls them into the talent pool. And they also don't try. They also won't apply. They've self-screened because this bias is so prevalent that they've been discouraged. Like I said, in the same way as someone who's long-term unemployed can be discouraged from the workforce. And so that's the data set we need.
You've studied in depth into this particular aspect, looks like, Vin.
I really have. And like I said, I am stretching my conclusions to that fuzzy edge of someone might be able to
but
do
I've
some
actually,
serious takedown.
yeah. So Vin, I've actually heard about this as well. I mean, I've heard studies, right, where women feel like they have to check all the boxes in the qualifications of the job description versus where a man may feel a little more overconfident and say, at least I know 50% of the requirements, I'm just going to apply anyway. So it's, I don't know if that is part of the mentality or the culture or the upbringing. I think there's so many factors which encourage, a man versus a woman's behavior in applying for a stretch role, right? Or a job that's beyond their current capabilities. I don't know, that probably has a factor in, just applying for that position and not being, it's almost like you have to put your ring in the hat, put your hat in the ring to even be qualified to.
Yes. And it's further than that. It is, you feel like you have to check all the boxes, but systemic bias will often make you not even look at the job.
Yeah.
And that's the bias we have to understand. People encounter that. It's in our heads. And we talk about imposter syndrome, but there is a step past imposter syndrome where I can be a data scientist and say, I don't know, am I really a data scientist? But the step past that is someone who is qualified, but won't say it, who is qualified, but won't even look at that job. They won't even look at it and evaluate what you just said, where you said, I'm looking at it and I feel like I have to check every box. There is a level past that where people who have been victims of bias, especially in their early formative years during education, they may have been barred access from education. And again, this is just barrier after barrier. And a lot of it is so deeply ingrained in us that there is this thing past imposter syndrome, where what you're talking about with women feeling discouraged from applying if they don't have everything. In some cases, that has gone so far that people will not even look at the job.
Yeah.
Because they don't feel like they belong. Yeah. They feel like there's no chance, so why bother? And this is what we're fighting. And this is why, I go back to IBM. They're dismantling so much of this infrastructure that has been there for so long.
Yeah.
And as much as we say they haven't made enough progress, we have to learn why. We have to face this sort of uncomfortable question of why haven't we made this much progress? Why are these assumptions data supported? Because we know instinctively this can't be true. Mm-hmm. Why are these things data supported, and where are the fundamental flaws in the data which are perpetuating our thinking and which are limiting us from understanding the impacts of systemic bias?
It's a work in progress, Ben. I think it's definitely,
yes.
It's a work in progress. Thank you for listening to today's episode. If you liked what you heard today and would like to hear more, please subscribe to our podcast on your favorite player like iTunes and Spotify. And please do rate our podcast. Also, please go to our website, www.datatransformerspodcast.com for more episodes, blogs, and information on our speakers. Thank you.